we're going to solve the value for the inequality and express the solution in interval notation and algebraic notation. So we have the absolute value of y minus 8 minus 3 greater than 0. Our first step is to put it in standard notation. So I'm going to have to add the 3 to both sides. That ends up giving me the absolute value of y minus 8 is greater than 3. And since it's greater, remember I gave you a little hint in your notes. Greater means or. That means that I'm going to solve y minus 8 is greater than 3, or y minus 8 is less than negative 3. I'm going to add 8 to both sides. Y equals, nope, not equals, sorry. Y is greater than 11, or on this side, add 8 to both sides. Y is less than 5. So in algebraic notation, we have y is less than 5 or y is greater than 11. In interval notation, this is going to be a union, and we're going to go from negative infinity to 5, and then we're going to go from 11 to infinity. Now we're going to take that same absolute value inequality and we're going to graph the solution set. I have negative infinity to 5, so I'm going to put a parentheses here that opens to the left at the negative 5, or 5, I'm sorry, not negative 5. And then I'm going to put a parenthesis that opens to the right at 11, and I'm going to shade to the right. And you will choose symbols for yours that will help you with this when you're in HOX. We have the absolute value of y minus 2 is less than or equal to 0. We are supposed to solve the absolute value inequality and express the solution in interval notation. Once again, have to put it in standard form first. I'm going to add 2 to both sides. That leaves me with the absolute value of y is less than or equal to 2. This is less than or equal to. This is an and statement, which means I'm going to have negative 2 less than or equal to y less than or equal to 2. And that is my solution. Now it wants it in interval notation, which means because these are less than or equal to symbols, I'm going to have a bracket, negative 2, comma, 2, and another bracket. The second step is to graph the solution set to the absolute value inequality. My solution set was negative 2 to 2. I'm going to have a bracket at negative 2 that opens to the right, and a bracket at 2 that opens to the left, and I'm going to shade between. This time we are considering the absolute value of x minus 2 greater than or equal to 0. So this is an or. I need to put it in standard form, which means I'm going to add 2 to both sides. That gives me the absolute value of x is greater than or equal to 2. Since it's an or, the two equations I'm going to solve will be x less than or equal to a negative 2, x greater than or equal to 2, because it's an or. That means I'm going to go from negative infinity to negative 2, and I'm going to put a bracket there. And I'm going to union that with a bracket at 2 going to infinity. We're going to graph that solution set. I copied over my solution, which was from negative infinity to negative 2, including negative 2, which means I'm going to have a bracket that opens to the left, and I'm going to shade left at negative 2. Then I'm going to have a bracket at 2 that opens to the right, and I'm going to shade to the right. We're considering the following inequality. The absolute value of 2y minus 9 minus 3 less than or equal to 0. So less than is going to be an and. I do have to put it in standard form, which means I'm going to have to add 3 to both sides. I have the absolute value of 2y minus 9 less than or equal to 3, which means the 2y minus 9 is going to go in the middle because it's an and. And I'm going to put less than or equal to 3 on that side, and I'm going to put negative 3 less than or equal to on this side. And I don't need to put the absolute value symbols in there. I'll take those out. And I'm going to solve this by adding 9 to all 3 pieces. That gives me 6 is less than or equal to 2y is less than or equal to 12. Then I'm going to divide by 2 on all 3 pieces, which gives me 3 is less than or equal to y is less than or equal to 6, which tells me in interval notation my solution is going from 3 to 6, and it includes the points, so it will have brackets. I copied my interval notation over here, and step 2 is to graph that solution. So I'm going to have a bracket that opens to the right at 3, a bracket that opens to the left at 6, and I'm going to shade in between. We're considering the following inequality. 4 times the absolute value of x minus 5 minus 12 is less than 0. So it's less than, so it's another and. It is not in interval notation, or excuse me, in standard form, so we need to do that first. I'm going to add 12 to both sides. 4 times the absolute value of x minus 5 is less than 12. Divide by 4. The absolute value of x minus 5 is less than 3. And since it is an and statement, the x minus 5 goes in the middle, greater than 3. Negative 3 on that side. So I have negative 3 less than x minus 5 less than 3. And I am going to add 5 to each piece. That gives me 2 is less than x is less than 8. So those are just strictly less thans, which means parentheses, 2, 8. So my solution was 2, 8. A parentheses that opens to the right at 2, a parentheses that opens to the left at 8, and I'm going to shade in between. This time I'm going to solve the following absolute value inequality. Write your answer in interval notation. If there's no solution, write NS in the answer box. It's already in standard form. I have the absolute value of y minus 8 is less than or equal to 2. So less than, so we have another and, which means I have y minus 8 in the middle, less than or equal to 2 here. I have a negative 2 with less than or equal over there. I end up with negative 2, less than or equal to y minus 8, less than or equal to 2. I'm going to add the 8 to all 3 pieces. It ends up giving me 6 is less than or equal to y is less than or equal to 10. And interval notation is going to be bracket, 6, 10, bracket. Once again, we're going to solve the absolute value inequality, writing our answer in interval notation, and writing NS if there's no solution. We have the absolute value of x minus 6 is greater than 9. So greater means or. It is in standard form. So my two equations are going to be x minus 6 greater than 9, x minus 6 less than negative 9. I probably should have switched those around, but as long as I put my solution in the right order later, I'll be fine. So I'm going to add 6 to both sides. X is greater than 15. Over here, I add 6 to both sides. X is less than negative 3. So x can be less than negative 3 or greater than 15. That means I'm going from negative infinity to negative 3. And those parentheses for both, union that with 15 to positive infinity. The next question, consider the following inequality. The absolute value of x plus 9 less than or equal to 0. So less than means and. We're going to rewrite the inequality in standard form and determine if there is a solution. It is not in standard form, so I need to rewrite it, which means I'm subtracting 9 from both sides. The absolute value of x is less than or equal to a negative 9. All right. Now, whenever we have something equal to or less than or equal to or greater than equal to a negative number, and we're dealing with absolute values, we have to think about it. Whatever I have over here with the absolute value of x, that's a positive number. So can that positive number ever be less than or equal to a negative 9? And the answer to that is no. We still write it in standard form, so I would still type in the absolute value of x less than or equal to negative 9, but my solution here is going to be the empty set or no solution. So we have no solution, and then here are our choices. They want you to sketch the graph, and this is the one that we want. This is the one there's no shading on that one, and that's the no solution set. So it's basically just a number line with no shading. We're going to consider the following inequality. 3 times the absolute value of x plus 2 minus 9 is greater than 0. So greater means an or. We're going to solve the absolute value inequality and express the solution in interval notation. Well, first step, standard notation. I'm going to be adding 9. 3 times the absolute value of x plus 2 is greater than 9. Divide by 3. The absolute value of x plus 2 is greater than 3. So that means that I'm going to have an or here. So x plus 2 less than negative 3, or x plus 2 greater than 3. Subtracting 2, I get x is less than negative 5, or subtracting 2 on the other side, x is greater than 1. In interval notation, that is negative infinity to negative 5, unioned with 1 to positive infinity. We're going to graph the solution set. I recopied my answers, negative infinity to negative 5, and strictly less than or greater than here, so we're going to use parenthesis at negative 5 opening to the left and shading to the left, parenthesis at 1 opening to the right and shading to the right. We have 4 times the absolute value of y plus 5 plus 6 less than 14. So this is an and. We need to solve it and put it in interval notation. I'm going to start by putting it in standard form. So subtract 6 leaves me with 4 times the absolute value of y plus 5 less than 8. Divide by 4. Y plus 5, absolute value of that is less than 2. So it's an and, which means the y plus 5 goes in the middle, which I have negative 2 less than y plus 5 less than 2. Subtract 5 from all of the pieces. Negative 7 less than y less than negative 3. In interval notation, that is negative 7 comma negative 3. Which means I'm going to put an open parenthesis opening to the right at negative 7, an open parenthesis opening to the left at negative 3, and I'm going to shade in between. In this problem, we have 21 is greater than the absolute value of 8 minus 4y plus 9, and I don't like that. I want to switch it around. So I am going to put 21 on the right, and I'm going to make sure that the symbol, like remember maybe when you're in grade school, the alligator needs to be eating the 21. And I'm going to put the absolute value of 8 minus 4y plus 9 on the left-hand side. So I've rewritten that as the absolute value of 8 minus 4y plus 9 less than 21, which means the same thing. Now I'm going to subtract 9 from all those pieces. That leaves me with the absolute value of 8 minus 4y less than 12. Less than, so this is an and, which means the 8 minus 4y goes in the middle. I have negative 12 less than 8 minus 4y less than 12. I'm going to subtract 8. It gives me negative 20 less than negative 4y less than 4. I'm going to divide by a negative 4. Now in your mind, you should be going ding, 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 ding. I'm dividing by a negative number, which means I'm going to end up changing my signs around. Negative 20 divided by negative 4 is going to be 5. I'm going to have the y in the middle. 4 divided by negative 4 is negative 1. And these symbols have got to switch, which we would normally write that with the negative number on the right. So negative 1 less than y less than 5. In interval notation, it's going to be negative 1 with a parenthesis, comma, 5 with a parenthesis. When I graph that, I'm going to have an open parenthesis at negative 1, opening to the right, parenthesis at 5, opening to the left, and I'm going to shade in between. Here we have 2 times the absolute value of y plus 2 plus 7 greater than or equal to 13. Great or, so this is an or. We need to put it in standard form, so I'm going to subtract 7. 2 times the absolute value of y plus 2 greater than or equal to 6. Divide by 2. The absolute value of y plus 2 greater than or equal to 3. And it's an or. So negative 3 less than or equal to y plus 2. Y plus 2 greater than or equal to 3. Let's go back and look at my first equation for just a second. I think I may have written that one wrong. I'm going to have y plus 2 less than or equal to a negative 3. And y plus 2 greater than or equal to 3. That feels better. Okay, so now subtract 2. Y is less than or equal to a negative 5. Subtract 2. Y is greater than or equal to 1. Which means we're going to go from negative infinity to negative 5 with a bracket. And union that with a bracket 1 to infinity. Which means I'm going to have a bracket at negative 5 that opens to the left, and I'm going to shade left. A bracket at positive 1 that opens to the right, and I'm going to shade to the right. Here I have the absolute value of 2x plus 5 minus 5 greater than 0. I'm going to have to put that into standard form, which means I'm going to add 5. The absolute value of 2x plus 5 is greater than 5. Clean that symbol up a little bit. All right, great or, so this is an or, which means that 2x plus 5 is less than negative 5, or 2x plus 5 is greater than 5. So subtract 5 from both sides. 2x is less than negative 10. Divide by 2. X is less than negative 5. Over here, subtract 5 from both sides. 2x is greater than 0. Divide by 2. X is greater than 0. So I have from negative infinity to negative 5 with a parenthesis, and then from 0 to infinity. Graphing that solution, I'm going to put a parenthesis that opens to the left at negative 5, shade that direction, parentheses at 0 that opens to the right, and shade to the right. Here I have 7 is less than or equal to the absolute value of 8 minus 4y minus 9. Once again, I'm going to flip that around, and I want the absolute value of 8 minus 4y minus 9 to be greater than or equal to 7. And then I'm going to add 9, which gives me the absolute value of 8 minus 4y greater than or equal to 16. So great or, so this is an or. That's an absolute value there. My two equations that I'm going to solve will be 8 minus 4y less than or equal to a negative 16, and 8 minus 4y equal to greater than or equal to 16. Subtract 8. I have negative 4y less than or equal to negative 24. Divide by negative 4. Y is less than or equal to 6. Over here, I'm going to subtract 8. Negative 4y greater than or equal to 8. Divide by negative 4. Y is greater than or equal to a negative 2. All right, so that seems like if I'm talking about an or here, all right, so my solutions weren't making sense to me, so I'm going back and looking at this work. And it doesn't make sense because I can't be less than 6 and greater than or equal to a negative 2. And I think my problem is right here. When I divide by a negative number, that bell should have been going off in my head. And so instead of being y is less than or equal to 6, this one should have been y is greater than or equal to 6. Same thing over here. I divided by a negative 4. So instead of y being greater than or equal to a negative 2, it should have been y less than or equal to a negative 2. And that makes more sense. And in this case, I'm going to have negative infinity to negative 2 with a bracket. And I'm going to union that with 6 with a bracket to positive infinity. So once again, I forgot that when I divided by a negative, I needed to switch the symbol. So just seeing my solution caught that mistake because I knew my solution wasn't making sense. I'm going to put a bracket at negative 2 opening to the left and shading left, and a bracket at 6 opening to the right and shading right.